Hi everyone. My name is Zach. Um, I chose to do my project on telescopes and observational astronomy, specifically the Hubble Space Telescope. Overview and background. The Hubble Space Telescope was named after an American astronomer named Edwin Hubble, who made important discoveries about the distant universe. In the early 1900s, Hubble realized that there are numerous galaxies beyond our own Milky Way galaxy. This discovery was revolutionary in the field of astronomy, and it earned him the nickname of the pioneer of distant stars. In 1990, the Hubble Space Telescope was launched and deployed into space by a space shuttle named Discovery. This made the Hubble Space Telescope a space-based telescope. Contrary to ground-based telescopes, Hubble does not have to face interference from things such as light pollution and distortions due to Earth's atmosphere. Development for the Hubble Space Telescope began shortly after Congress granted funding for NASA's portion of the telescope in 1977, which was simply named the Large Space Telescope at the time. Although NASA was hopeful that the telescope would be launched by 1983, it was not until 1990 that the Hubble Space Telescope was finally deployed into space. The dimensions of the Hubble Space Telescope are 43.5 feet in length, a weight of 24,500 pounds, and a maximum diameter of 14 feet. You can see here in this picture, this is like comparing the size of the Hubble Space Telescope to a school bus. So you can see it's about the same size. So pretty big. The initial cost to build the telescope was $1.5 billion, but there were many ongoing costs. The instruments included on the Hubble Space Telescope were the Wide Field Planetary Camera, Goddard High Resolution Spectrograph, the Faint Object Camera, Faint Object Spectrograph, and the High Speed Photometer. Shortly after the Hubble Space Telescope was launched and began operating, astronomers realized that all of Hubble's images came back extremely blurry. These photos were so blurry that it rendered them almost useless. The cause of this problem was identified as the telescope's main mirror. The defect in this mirror, caused by a manufacturing error, was so small that it was off by only about 1/50th the thickness of a piece of paper. 3 after Hubble's deployment into space, in December of 1993, NASA launched its first mission to the Hubble Space Telescope, its first service mission to the Hubble Space Telescope. This 7-person crew installed 2 new cameras during the fix of the telescope's initial shortcomings. Almost immediately after the service mission, Hubble released images that were unlike anything astronomers had ever seen before. So far, there have been a total of 5 astronaut servicing missions for the Hubble Space Telescope. The first one was in December of 1993. The second one was in February 1997. The third was in December of 1999. The fourth was in February 2002. And the fifth one was May 2009. In Hubble's 30-plus years of operation, its capabilities and lifetime have expanded far beyond the initial hopes for the project, thanks to these servicing missions. The Hubble Space Telescope's range of light that it can detect ranges from ultraviolet through near-infrared light, meaning that it can see much more than what the human eye alone would be able to see, which is visible light. Connection to course material in this class. So in Module 9, we learned about light in astronomy. As explained in this part of the class, most astronomical objects are simply beyond our reach, with many of them light years away. Even the fastest spacecraft that humans have ever created would take about 100,000 years just to reach the nearest star. However, while we may not be able to visit some of these distant astronomical objects, we can still learn much about them. From a distance, we can use numerous different techniques to analyze objects in the cosmos. One of these techniques is by looking at them through a telescope. The radiation from objects, like light, can be decoded to tell us many important aspects about an astronomical object. Light, which is electromagnetic radiation, is generated by processes at the atomic level. We also learned in this module that in astronomy, radiation is waves of light that radiate outwards from a source. When we look at this light through a telescope, we can decode things such as a star's chemical composition, its temperature, and even its relative motion to the Earth by measuring the redshift or blue shift of a star. As the Hubble Space Telescope is one of the most powerful telescopes that we currently have, we are able to detect very distant objects that are otherwise too faint to be seen. In fact, the Hubble Space Telescope can see objects that are up to about 13 billion light years away. And it is important to remember that the universe is only about 13.8 billion years old. In Module 9, we learn about how the propagation of light works. As you may remember, light propagation follows an inverse square law, meaning that if the distance between an observer and a light source doubles, the apparent brightness of the object will diminish by a factor of 4. So it is clear to understand that in order to see objects extremely far away, especially billions of light years away, you need an extremely powerful telescope. The significance. The Hubble Space Telescope has had a tremendous impact on astronomy since it began over 30 years ago. As well as providing astronomers with pictures of the most distant galaxies ever seen, Hubble has helped to settle debates and confirm theories in the field of astrophysics. In the year of 1995, the Hubble Space Telescope peered into a seemingly empty and dark piece of sky for 10 days. Many astronomers thought that this would be a waste of time and that very little would be found in this patch of sky that seemed to be void of any light. The result of this was shocking. After the 10 days, Hubble revealed that this once seemingly dark patch of sky was far from empty, but rather was filled with a plethora of galaxies, all of which had never been seen before and were some of the oldest galaxies and stars ever discovered. This gave new light to how many galaxies there truly are in the universe. The age of the universe is something that has been estimated for many years prior to the release of the Hubble Space Telescope. Many of these estimations and calculations varied widely. The powerfulness of the Hubble Space Telescope allowed astronomers to pinpoint the age of the universe. After looking at some of the most ancient stars in the universe, astronomers were finally able to agree that the universe is approximately 13.8 billion years old. Hubble also provided evidence that galaxies have a supermassive black hole at their center. By studying supernovae, Hubble was able to contribute to astronomers' theories about the mysterious, yet vastly important dark energy. And these are my works cited. Thank you.